Hey all, I know it's Friday evening and most of you will be like, feet going up. I'll try to make my talk as interesting as possible. As Courtney introduced, I'm Raji Balasuubramaniyan and I work as a data scientist for Manheim. And you've been hearing from morning different talks about machine learning have been used in various industry. I'll be introducing about like how we used in our industry is vehicle auction industry. Okay, so first I'll introduce what we do, vehicle auction industry, especially at Manheim. And then I'll actually introduce like some of the machine learning use cases that we used, for those we used for some of the problems. And then how we approached the problem, like what are the algorithms we used and what are the results. I'll just give a glimpse. And then actually, if the time permits, we can have a Q&A. Okay, so many of you don't know what we do. I work for Manheim. Manheim is a vehicle auction. They do about like 85% of auction that happens in USA, like it's through us. We connect users, buyers and sellers. We actually not only do inline auction, that means like users basically go there and kick the tires and bid and buy the vehicles. But we also do online auction where you can basically log into the site like kind of eBay and then bid. And there's one more product we have, which is like a webcom based, we call like simulcast, in which you basically visualize the real physical auction through webcom, and then you can basically bid on any of the vehicles you like by sitting at home. So these are some of the products we have. And to tell you more, like about 85% of the whole vehicle auction happens at Manheim, and we are the leader. And we have about like over 100 physical locations over US and Canada, where users go almost like everyday basis, and then they actually bid on the car and win the car. So we connect, we facilitate buyers and sellers in one place. That's what we do. And about 15 million cars go through auction every year through us. So that's what we do. Okay, this is interesting, and this is basically like a website where it's a member-based industry. So you have to actually be a member. You have to pay money so that you can come there, either in the physical auction or in an online auction. You have to pay money. It's a membership-based industry. So with that, if in any membership-based industry, one of the biggest problem actually we face, or our sales force, our marketing team faces, like churn rate. So what is the churn rate? Churn rate is basically like at a given period of time, how many customers stay by being a member versus how many customers leave. So that's basically the churn rate. And this is so important for any membership-based business because they actually like survive by memberships. So it can be like a cable, it can be TV subscription, it can be any, this applicable to any businesses. In our case, like we come across this problem from the sales team because the sales team basically like want to see like, hey, how many users are going to churn? Can you predict it? That's how actually we came to the problem. So they basically came to us, and they are the domain experts to us, according to me. And we want to make the customers happy. That's our motto. So how do we make the customers happy? By if we know like they're going to churn, then we'll ask the Salesforce team so that they can go and coach the customer, saying like, hey, it seems like there is something wrong with your behavior, so you should basically train on some of these parameters so that you will be you won't churn. This is one of the examples I would say. Okay, so we know the problem, that's the churn rate. We want to actually predict how many users are going to churn, or how healthy are they happy or not, or they are not happy. So how do we approach the problem? Using machine learning. So as in any machine learning problems, the first and foremost thing we have to do is like collect the data. In our case, the data is basically the behavior of the customers, like how many times they come into the auction, that's an activity, how many transactions they make, how many times they buy, how many times they come and showcase their vehicle in the auction. So that is like how active they are, and how the messages are in between buyers and sellers, because that is sometimes if one customer is just keep on giving bad messages, it's going to churn the other one who is receiving the messages. So that's also so important for us. And how response they are, because sometimes like one person basically like bids and bids and bids, but there is no response from the other person or the seller. Then this guy is going to be, okay, this is not going to be lucrative to me, so I'm going to churn. So these were some of the parameters, and we get all this information, our domain experts or the salespeople. So we go and interact with the salespeople and say like, okay, what do you think? What are the parameters? They are very important, or that makes the customers churn. So we collect all these parameters. So we have different time periods. We have collected the data. So I'll actually come into that in the later part of the talk. But we have like 30 days, last 30 days transaction activity, how the responses are. So we collect all the data and we create profile. So now we have the profile. Now we have to actually segment them without any prior knowledge, because we want to see whether there is any pattern we see. It's the second step we do. And then we used actually the unsupervised behavior k-means clustering. And once we know which segment a customer belongs to, now we want to know with respect to cancel members and a current member, is there any change in pattern behavior? Is there some pattern influence, a cancel member versus a current member? That is actually we do via supervised learning. We actually used a logistic regression and a neural net for this purpose. Then actually I already told you about the sentiments that passed between buyers and sellers. If this is actually the buyer is again and again passing bad sentiments or bad messages, then the other person is going to churn. So the sentiment analysis also we took into consideration for predicting or arriving at a churn rate. Okay, so now I gave actually the approach. We actually took the various algorithms we used. I'll actually talk about the algorithms. This morning actually we heard a very good talk about the k-means clustering. So in our case, we use the k-means clustering. What it tries to do is like, given a profile, it tries to put in either one of the clusters, given so that the within cluster sum of square is minimal, so that we all know. So, but deciding how many number of clusters or k is the biggest problem anyone have. So what we did is like we tried different numbers, and every time, once we arrive at the cluster or groups, we consulted with the Salesforce people. Okay, is this making sense to you? So although it's unsupervised, I won't call it as unsupervised because it's a semi-supervised. We had prior knowledge or knowledge about the clusters from the salespeople. So they know, oh, it seems like this seems to be a successful buyer, and this is a successful seller. So we finally arrived at 5 groups. First being successful buyer, that means like he always comes in, always wins the vehicle. So that's a successful buyer group. Successful seller, so whenever he is posting the cars, he is going to sell it. So that is a successful seller. And buyer at risk, he was actually buying very good previously, but he is not doing any good business now. So he is a risky guy now. So that is a buyer at risk. And seller at risk, basically like he was really selling good, but not selling now. That's a seller at risk. And fifth is category. Some people like they just come and they just don't do any business. They just come there for the sake of it. So that's the 5th category. And this we could come up with from the help of the salespeople. So this is, although it's unsupervised, I would call it a semi-supervised clustering. Okay, now we know which group, whether he's a seller, buyer, or seller at risk, buyer at risk, we know like which group he belongs to. Now we know how many users recently churned, that's all the cancel members, and we know how many are current members. So we have two groups, cancel members and current members, and we just use a logistic regression in this purpose, very simple, like with 0 being actually cancel member, 1 being actually current member, and see like is there any influence in the parameters we use. And once we have it, like all the parameters are activity, what's the response time, so it's all the straightforward parameters which we used for our segmentation. Okay, so we could also use actually neural net for this purpose, where our neural net is basically learn from the parameters and apply different weights and differentiates whether he is actually like a cancel member or a current member. Okay, so I actually mentioned about sentiment analysis. So in this case, we basically have two groups, again, cancel member and current member, and we have basically terms. Terms like, I don't like this car, I hate this car is bad. That's all bad sentiments for us. And the good sentiments is, oh, I love this car is so good, the interior is so good. So those were the good sentiments. And we just calculate the probability using what is the probability of a good term being used. He is a current member, and the same good term being used, he is a cancel member. The same thing, what is the bad term being used, he is a cancel member, and the bad term being used is still a current member. If we actually come up with all different probabilities, we used actually an A-base for this purpose. And once we have all these things, we could actually like, our aim is to find the best group for the message, so that actually we used a maximum A posterior for this purpose, which is similar to like a maximum likelihood, but it uses prior knowledge also. So given a message, we want to actually put it into any group, and then we give a score, which is a sentiment score we call. So now we have grouped the users, and we have actually like learned according to like what kind of either he's a cancel user or he's a current user, and then we actually have a sentiment also. So we collectively have a health score, churn rate. So as I explained, that we have for every dealer, we assign a group: seller, buyer, seller at risk, buyer at risk, undecided, and we calculate 3 different scores here, like 0 to 30 days. So that is calculated using the recent data, so last 30 days data, how his behavior is, and 30 to 60 days, and 60 plus days. So why this is so important is like some users were so good in the past, like last 30 to 60 days, but now they are not doing any business. So in this case, like we'll let the Salesforce team know, like, hey, this seems to be there's a problem with this guy because he is from the successful category to risky category now. So please like concentrate on this person. And what they do is like they call these people and they say like, hey, it seems like you're not coming to auction for last few days. What's happening? Is there anything we can help? So that's what the Salesforce people do. And the marketing team, they'll also be notified, and they actually like accordingly they'll offer promotions, and they actually, because we want to keep the customers happy. That's the ultimate motto we want. Okay, so that is the first problem. The second problem is the recommendation. Like as you all know, like it's been many talks from morning. You've been hearing recommendation. So it's kind of a filtering where you'll get stars for any item. So in our case, once the user logs into the system, or once the user goes to the auction, he'll be given something like all the recommended items to him. So that way, actually, he don't have to go through all the inventory and look for like what he likes it. Instead of that, we already provide him, okay, these might be interesting to you. So then he can actually go to that particular auction and then just bid on it and win the vehicle. Okay, how do we approach this problem? Actually, step 2 and step 1 can be interchangeable. Basically, like we collect data. Irrespective of any ML problems, this is the first and foremost thing. We collect data. This case, like transaction data. So we collect whatever period of transaction. In our case, we collect last 90 days transaction. Like what we collect, what kind of car he bought, what year, make, model he bought, which auction he bought, and from which region he bought, everything. And not only the transaction, we also collect information about how many times he searched for that vehicle in our website. So that is basically the search data. And how many times he saved some vehicle. So that's the saved search data. So we collect everything about even the VDP clicks. We collect everything, all the data related to every user. That's the data, because without the data, you cannot predict anything. There is no data science. So we collect every data. And once we collect the data, we segment them again without any knowledge. Although I say without any knowledge, it's a semi-supervised. We provide some knowledge from the Salesforce people. And we segment the data. And then once we segment the data, we have to then match. For every segment, we go and take one user and look at his profile. And with respect to the current inventory, we match. Like whether this, let's say like one guy always want to buy 2011 Honda Accord. And in our inventory, we don't have a 2011 Honda Accord, but 2010 Honda Accord. But how much it is similar? That is basically matching. So we actually do the matching. And we might actually find for one user hundreds of cars chosen for matching his profile. Then we have to sort in some order so that the most relevant content will come in the first. So once he logs in, he will get only the most relevant content, not all the cars which matches his profile. And we combine matching, ranking, or sorting, and we actually do the recommendation. That's how we do. Okay, so this is already, like I mentioned, we used k-means clustering for this purpose. In this case, it's only 3 groups. That made sense to us. So we didn't go for more than 3. It's like whether he's a franchise dealer, whether he's an independent dealer, or he's a wholesale dealer. That's it. That itself gave us enough clarity, so we actually stopped with 3. And so now comes actually the very basic step of collecting the data. I already explained how we collect last 90 days transaction. And we have collected a profile. Profile can be all the vectors, so you can actually be what year, what make, what model, which odometer range he bought. And these are actually the facets we call. So every profile will have different facets, and every profile, let's say 10 profiles one user always buys. So then we go to the current inventory and then see how many of this profile and that profile match. We use collaborative filtering for this purpose. Actually, there was a great talk this morning from Facebook about the collaborative filtering. We used actually 2 types of collaborative filtering techniques: user item collaborative filtering and user one. And user item is basically this guy always bought car X. How many times he bought car Y also? It's basically Honda car he bought. How many times he bought Toyota Camry also? So that's basically a similarity you can basically go for. We did similarity or co-rating matrix. That's the one use. And the next one is we could always go for user similarity. That is, if user profile X and Y are similar, how many, if Y is buying a different car, then we can suggest that to user X too. So that is the user collaborative filtering. I'm sorry, I'm running out of time. And then we now have created actually the profile grid, but then we have to actually find only those cars that are more relevant to him. So we can have different sorting techniques. Some people just want to buy cheap cars. Some people want to buy expensive cars. But in our case, in this one is basically made with profit. So everybody wants to make a profit. So they buy cheap from the wholesale. They want to sell it good in the retail. So what we do is we just used linear regression for this purpose. So our regression goal is profit. given the wholesale price, what is the retail predicted price, and what are the other parameters, how much work is being done on the car, we basically run actually a regression and predict actually score. That's what we do. Okay, so as a result, once the user logs in the page, we'll just suggest relevant course. I'll be very quick. So the third problem I want to talk about is forecasting. Forecasting has been very famous in all the stock markets and all, but here we do forecast of like how many, given a past history of the transaction made by a user, how many he's going to do in the future. Simple. So we can do like not only how many he is going to do in the future, but what are the year make models he is going to do, and which auction he is going to do. Any kind of forecasting you can do. And the other way, like we can do actually the forecasting of churn rate, because churn rate is very important for Salesforce and marketing. If we can predict like this many users are going to churn in next 2 weeks, they are be alarmed. And they say like, oh my God, then there is something going wrong. Then marketing team will be notified and offers will start to flow. So this is very, very important. And so it's synapses of time series and Arima. I think I don't want to go in detail because it's time running out. So we used actually Arima for this purpose. A quick glimpse is like according to signal, we basically apply different non-seasonal and seasonal parameters for our Arima, and then we actually choose the best model that has the lowest RMSE, and then actually using the 80-20 rule. That's what actually I want to make sure. So this gives an example of the whole transaction pattern of a user for 80 weeks, and then this is the forecasting we did for the next 20 weeks. And in order to predict which model doing best, we use actually take 60 weeks of data and train our model, and then predict the next 20. So that's an 80-20 model, and we predict we get only the lowest RMSE model, and then we use that model for predicting the forecast. That I just want to summarize. We used various ML techniques for our industry, vehicle auction industry, and choosing an algorithm basically determines the success of your ML problem. And according to use case, you can choose different kinds of a different variety of algorithms. And this is actually one part of one slice of the pie, because extracting, cleaning, and normalizing is the biggest headache. Everybody knows, like whoever handled with the data. And according to whatever the techniques you use for all these things, your results might vary. And that I'd like to actually thank Dr. Stefan Peinel, our PO, and for his encouragement, and I would like to thank our wonderful Sonar team and Manheim for the opportunity. And I thank you for your attention.